Right, we're going to question number 4. A student is given two aqueous solutions, L and M, that both contain iron salts. The student does a series of tests of the solutions. The table shows tests and observations. So you go add ammonia solution slowly until excess. Okay, you in the first you get observation with L, you get red-brown precipitate forms that is insoluble in excess. Observation with M, you get a green precipitate forms that is insoluble in excess. Add sodium carbonate, you get red-brown precipitate. Effervescence is seen, a green precipitate forms of 4M. Then add diluted acid and divide into two portions. No changes seen here, no changes seen there. Add barium chloride solution to a first portion, which is no changes seen in L, but white precipitated forms in M. Add silver nitrate solution to the second portion, you see a white precipitate forms, no changes seen in there. Okay, so identify L and M using results table 1. In your answer should identify all precipitates, explain why effervescence is seen in reaction sodium carbonate with L but not M, and give ionic equation all reactions. So there's 6 marks in here, so you will answer quite a few things. So let's start, I sort of sort out it this way. Let's start with observation with L. When you add excess ammonia, you got this precipitate form, which is the brown precipitate, FeOH3, H2O3, brown precipitate. That is insoluble with excess NHS, NH3, not NHS, NH3. The ionic equation for this is your iron, 3 plus ammonia, gives you this, so basically replaces ammonia into there. Ammonia takes away the hydrogen, forms 3 ammonium ions, and leaves 3 OHs there. So this is your brown precipitate, okay? Now you have B, reaction with sodium carbonate solution, a red-brown precipitate forms, the E and effervescence. The brown precipitate forms is this one here, and carbon dioxide gas is effervescence. So the reaction is Fe with 6 waters, 3 plus carbon dioxide gives you Fe with 3 waters, OH3, and plus 3 carbon dioxide plus 3 waters. So those are the equations for that, for the reaction with sodium carbonate. Now it says here, addition of silver nitrate solution, you see a white precipitate, which is AgCl. Ionic equation, this one here, Ag plus Cl minus gives you AgCl. Now for L is FeCl3. That's the conclusion you get to from those tests. So observation with M. With excess ammonia, you see this precipitate, which is Fe with 2 OHs and 4 waters, which is a green precipitate is formed, insoluble in excess ammonia. You have to know all the reactions. You have to memorize them, okay, so you can identify them. So this is equation, ionic equation. So you have FeOH2O, 6 waters, Fe2 plus ammonia gives you this precipitate, which is a green precipitate, plus 2 ammonium ions formed. So this ammonia will take away 1 hydrogen from here. So if you got 2 ammonias coming out, you got 2 hydrogens coming out. So therefore you got 2 ammonium ions there. Reaction with sodium carbonate, this is equation. So you form a green precipitate, which is FeCO3 plus water. Reaction with barium chloride, you see barium 2 plus SO4 2 minus gives you barium sulfate, white precipitate. So M is, because you got a presence of sulfate, so it's going to be iron, because you tested that for iron first, and then it's sulfate. So M is FeSO4. And then you got reason for Fe3 produces CO2 and Fe2 plus does not. Fe3 plus in L is more acidic than Fe2 plus in M. Fe3 plus is smaller ion than Fe2 plus, therefore more polarizing, therefore making Fe3 plus ion a better proton donor. Okay, so that's the answer to that question. So that should cover all the 6 marks they wanted you to answer. Okay, so you answered everything. You answered all the precipitates have been answered. You say why the effervescence is seen in one reaction with sodium carbonate with L but not with M, because you got the explanation here in here because of the ion size. And then you say give ionic equation for all reaction. We've done all the ionic equation for all the reactions. I hope that helps you, but you have to know all the transition metal reactions and then just use that to explain this question better. Okay.